Good afternoon. You are watching a V.O.Chidambaram YouTube channel, and myself Dr.A.Mathavan, Associate Professor and Head Department of Chemistry. Today I am going to discuss about the representation in the group theory. So what is, first of all, what is the group? So group is a collection of elements. So in the case of molecule, so the elements which are represented as symmetry element on the basis of structure. So every molecule which has a number of symmetry elements. What are the symmetry elements? The symmetry elements are identity element, proper axis of rotation, plane of symmetry, improper axis of rotation, and center of symmetry. These are the elements which may or may not be present in the molecule, depends upon the structure. So the elements which are present in the molecule, they form a group. So this means the elements which has some collection of elements which obey certain properties, they form a group. So these symmetry elements which is present in the molecule, which can be represented by a matrix, that is called representation of a group. It is called representation of a group. So usually here the molecule which can be represented by using the coordinates. So that is a structure which can be given in terms of coordinates like x, y, z, a three-dimensional arrangement. So this actually molecule which can be representation on the basis of a matrix. A representation is a set of matrices, each which correspond to a symmetry operation and combined in the same way that the same symmetry operation in the group combined. This is actually called as matrix representation. That is actually here the symmetry elements which can be represented in terms of matrix. So what are the basis for this representation? So the basis means the coordinates using the molecule. So usually we are using the three coordinates x, y, z. That is a three coordinates we are using, or we can use either one coordinates or maybe equal to the two coordinates or more than three coordinates. That is multi coordinates we can use to give the representation of symmetry elements in the group. So here actually that means all the symmetry elements we are giving in terms of matrix. So that is actually the matrix. One of the important properties of the matrix is the character of the matrix. The important property of a square matrix is a character. What is a character? Character is the sum of the diagonal elements which present in a matrix. This can be represented by a symbol psi. So some of here actually the C2V, the point group. So actually water molecule which belongs to C2V point group, which has the four symmetry elements E, the identity element, and proper axis of rotation C2 axis, and sigma V. Sigma V is there, it is a plane of symmetry along the coordinates x, z, and sigma y along the coordinates y, z. These are the four symmetry elements which are present in the water molecule. Not only that, so what means belongs to that molecule has C2V point group. This C2V point group symmetry element has been represented by a matrix. So what are the matrices is given that. So which has, in the case of identity element, the matrix using the three coordinates like x, y, z. X, y, z. So on the basis of that, here 3 into 3 coordinates, 3 into 3 matrix given here, that is 1 0 0 0 1 0 0 0 1. So here sum of the diagonal elements in this matrix is 3, that is given in the case character. Similarly in the case of C2Z, and on the basis of here the character of the rotational axis is the 2 cos theta plus 1. Here cos theta is equal to 180 degree, but 2 cos theta here is actually, that is a minus 1 minus 1. The cos theta 180, cos 180 is equal to minus 1, that is a minus 1 minus 1 1, that should be equal to cos theta minus 1 plus 1 should be equal to minus 1 here. This character should be equal to minus 1, that is character. And similarly in the case of sigma v, the character should be equal to 1. Similarly in the another character is also 1, sigma v is also 1. So this is actually the character of the matrix which corresponding symmetry elements which present in the C2V point group. These are what do you mean by character this. So usually here the representation we are giving in terms of like that. So what is mean by, there are two type of representation, one is reducible, another one is irreducible representation. So what do you mean by here, whether the representation can be reduced into smaller manner or smaller manner means in the case of we can use multi coordinates. So multi coordinates, that is you can get the representation, or in the case of the same representation can be number of coordinates which can be lower number, we can also. So that maybe the representation either can be reduced into smaller dimension is called as reducible. So those representations which cannot be reduced into further, which is called as irreducible representation. There are two types of representation. So normally here the character which corresponding identity operation is called as dimension of the representation. The character of the matrix which corresponding identity, that is identity element, the first one is there, which is called as a dimension of the representation. Suppose we can use only one coordinates, we can get 1 into 1 matrix, the character is 1, this is called one dimensional representation. Suppose we can use the two coordinates, that is x, y, we can get 2 into 2 matrix, that is a character which corresponding that matrix 2, which is called two dimensional representation. Similarly, in the case of we can use 3 coordinates x, y, z, they form actually 3 into 3 matrix, the character which corresponding that matrix is the 3-dimensional representation. So we can use also multi-dimensional also, more than one coordinates also we can use, that is a. So suppose in the case of one coordinates 1-dimensional, 2 coordinates 2-dimensional, and 3 coordinates 3-dimensional, more than that we can say called multi-dimensional representation. So all the multi-dimensional representation which can be reduced into lower, which is called reducible representation. Generally all one-dimensional representations are called as a irreducible representation. So these representation which can be represented by a symbol which is given by Mulligan. So on the basis of the character, whether the character should be, so whether character is 1-dimensional or 2-dimensional or 3-dimensional, or depends upon the character whether it is a +1 or -1. So character is positive, which is called as a, what you mean by symmetric with respect to particular symmetry operation. Suppose the character is negative, that is -1, which is antisymmetric with respect to symmetry operations. So on the basis of here, suppose in the case of when the molecules are non-linear, so here the dimension of the representations are there. So all one-dimensional representations are A or B. 2-dimensional representations are given as E, and 3-dimensional representation is T, and 4-dimensional representation is Z, and 5-dimensional representations are H. Here only 5-dimensional representation up to that only given. Similarly, in the case of that molecule which having inversions or center of symmetry, here we can use, suppose in the character which correspond to I is +1, that is a symmetric, the subscript G is used. G is means the rate, that is even. And -1, the character which corresponding I is -1, which is antisymmetric, the subscript U is represented as, that is called AU, AG, or EU, EG, TU, TG, like that. So ungerate, just like that. Similarly, in the case of, suppose we can consider in the case of the molecule having the sigma H as a symmetry element, the symmetric with respect to symmetry element sigma H, it is superscript prime is used. Suppose the antisymmetry, that is -1, character is -1, it is superscript double primes are used. So in the case of for one-dimensional representation, so it depends upon the character which is corresponding proper axis of rotation. If suppose symmetric A can use, previously you can say A or B can use for one-dimensional representation. When that for one-dimensional representation, the proper axis of rotation, suppose the character is +1, that is positive, that is symmetric with respect to Cn, it should be A, and antisymmetric, it should be B. Similarly, in the case of for one-dimensional representation, symmetry with respect to most important perpendicular C2 axis. That C2 axis also there sometime maybe in the case of more than that C2 axis or n C2 axis which are present in the molecule which is perpendicular to the Cn axis, which is symmetric, the subscript should be equal to 1, antisymmetric subscript should be equal to 2. Similarly, in the case of our B representation, that is in the case of one-dimensional representation, if there are 3 equally important perpendicular C2 axes, that is C2x, C2y, C2z are there. But suppose symmetric with respect to C2 is subscript 1 is used. Suppose in the case of symmetric with respect to second C2 is or subscript 2 is also used, and in the case of symmetric with respect to third C2, the subscript 3 is also used here. So another one is next in the case of two-dimensional representation. The character of the Cn, that is a proper axis of rotation, the operation for that is actually proper axis of rotation. On the basis of that we can use, depends upon the angle, 2 cos 2 pi n subscript 1 is used, and 2 cos 4 pi n the subscript 2 is also used. And similarly, in the case of 2 cos 6 pi n for subscript 3 is are using. Sometimes maybe similarly for subscript 4 or 5 we can also use in the case of 5 means in the case of E representation. Or for in the case of T or F higher representation, the character which is corresponding to C4 axis, or sometime maybe that is not possible, you can consider S4 or C5 also. But suppose it's positive subscript 1 you can use and negative subscript 2 is used. For in the case of linear molecules, so far we discussed in the case of non-linear molecule. Suppose next you can go through linear molecules. So dimension of the reducible representation we are representing here, one dimensional representations are which are sigma, which is equal to identical to A, and two dimensional representation, that is pi delta p, which is identical to E, and symmetry with respect to sigma v is symmetric with respect to sigma v. We can say symmetric, we can superscript we can use the plus, and antisymmetric minus 1 we can use. So in the case of minus sign antisymmetric and plus sign for a symmetric, like that. So here is also some of the example is given here in the case of C to B point group. So what do you mean by A, B, C is given here. So A actually one of that the character which corresponding E symmetry identity operation, and C2 Z is minus 1 and sigma V is 1 and sigma V minus 1. This is actually one dimensional representation. That means the character which correspond identity operation is 1, which is one dimensional representation. So here actually the symbol which correspond to the Millikan symbol which corresponding this representation is B1. This is a B1. And next what he called as a representation, another one is B, that is actually here the character is with respect to C2 Z is antisymmetric, and sigma V is also antisymmetric and used here B2, can use B2 here. So C, what do you mean by here, third one is all our character is 1 1 1, this is actually A1 representation. This is actually called as totally symmetric representation. When all the character of the operation, the character of the matrix which corresponding the symmetry operation is positive, that is 1 1 1, which is totally symmetric representation. All point group has this totally symmetric representation. So next in the case of C3b point group, there are two representations are here. One is actually here 2 dimensional. Why? Because it cannot be further reduced in the case of C2b. So what are the basis x and y which are the basis for this E representation? So this is actually 2 dimensional representation. The characters will be, they are corresponding to identity operation is 2. So that is called, this is a 2 dimensional representation which can be represented by E symbol. And for second one is all are 1 dimensional representation, it is A1. So this is actually the irreducible representation in the case of C3b, and the previous one it is C2b. So that is actually. So next actually here the reducible representation, normally in the case of reducible representation it can be reduced. Reducible representation which can be reduced into lower dimension by using a standard reduction formula. So normally here what are the uses of this irreducible representation? That we can say the representation of symmetry elements which are present in the particular point group. So what are the uses of it? So the uses of irreducible representation which communicate the molecular properties in the group theory. Molecular properties in the group theory. That means in the case of a vibrational analysis, hybridization, energy calculation or electronic transition, that we can be represented again. So next, every irreducible representation made up of 2 or more irreducible representations. That means actually reducible representations are the linear combination of irreducible representation. That is, reducible representations are the linear combination of irreducible representation. All 1-dimensional representations are irreducible representation. We cannot further reduce. So 2-dimensional representation can be reduced. 3-dimensional representation can be reduced, but 1-dimensional representation cannot be reduced, that are called as irreducible representation. There are infinite number of reducible representations are possible for a point group, but irreducible representations are finite for a point group. This is actually the number of classes which present in the point group that equal to number of irreducible representation. This is one of the rule. So number of irreducible representations that can be found out by number of classes. This number of classes can be determined by using one of the procedure is called as similarity transformation. So we will discuss in the next slide. Thank you. Thank you very much.